Welcome to day 2 of types of reaction demos. Miss Raymond and Miss Schwem here, your favorite chem teachers. And our first demo that we're going to do, I need a dollar bill from somebody from the audience. Who's got a dollar bill that I can borrow?
Wait, I have some money in my wallet. Let me check. Oh, I only have a 20. Is that okay?
Oh yeah. 20's fine.
Okay.
20's perfectly fine. Thank you.
Wait. It's not, nothing's going to happen to it, is it?
You'll get it back in some shape or form, okay?
Uh-oh.
You'll get it back in some shape or form. So, I call this one hot dollar. Now, you might ask, why do we call it hot dollar? I'm going to go ahead and put it into the beaker here, and I've got a solution, and it is an ethanol solution. And ethanol is a type of alcohol, and I'm going to let that sit in there. Now, put the money in there. Make sure it's nice and wet. It's looking good to me.
Wait, isn't ethanol flammable?
Perhaps.
Uh-oh.
Now, did you know that it's illegal to burn money? But I won't tell if you won't. All right, let's see what happens. Oh my goodness!
Oh, what? Oh, it's okay. How did that happen?
So I burned the bill, but I didn't burn the bill?
Wait a minute.
Now if I try it again, nothing happens. So what did I burn?
Not the paper.
Not the paper. I must have burned the ethanol and not the paper. So, okay, now, if I burn something, what am I reacting it with?
Oxygen. We did that yesterday.
You got it. We did that the other day. So, we burning it, that means that it's reacting with oxygen. If it's reacting with oxygen, what type of reaction is it?
It's a combustion.
Combustion is correct. And this is combustion of a hydrocarbon. And the reason why I know it's combustion of a hydrocarbon is because my ethanol, I can see here, has carbon and hydrogen and oxygen in it. Sometimes hydrocarbons are only carbon and hydrogen. Sometimes they have oxygen as well. Now, we remember the other day when we have combustion of a hydrocarbon, it always makes two things. And what are those two things?
Carbon dioxide and water.
You got it. Now, the carbon dioxide is a gas. And then, of course, water, because I don't see the water coming off of it. But that heat, it's so exothermic that it's vaporizing that water, so that water is gaseous. Okay? So, go back, balance the reaction, and we're all done. So that might have been just a little too hard to see. So we're going to try this just one more time, just to be able to see it a little bit better. So if somebody can turn off the lights for us, take my money back out. My money. And with the lights off, we'll try this one more time. I've got the dollar bill in the solution of ethanol. And I'm going to take it out. And we're going to see if we can see it a little bit better here. Ooh, there we go. That looks much better. Okay, so we've got our burning dollar bill. But the dollar bill is fine. So the alcohol's burned, the dollar bill do not.
It's raining solids. Alleluia, it's raining solids. Okay, sorry, I don't have a good singing voice, but this one excites me a lot. So we have here a cobalt 2 chloride solution, and we have a sodium hydroxide solution. So thinking back to the other day when we did our reactions, you should be able to tell me what type of reaction this is if I have two aqueous solutions that are combining. So one compound with another compound, and we have some displacement, double displacement occurring, or double replacement. So I'm going to start with my sodium hydroxide, clear, colorless solution, and I'm going to pour some into my test tube, and then we're going to add our cobalt 2 chloride, which hopefully you can see it's a pretty like pinkish color of a solution. And then I'll try to bring this closer for you, so you can see the reaction that's going to occur. So pink solution, colorless solution, and hopefully against my apron, my lab coat, you can see that we have a blue precipitate forming. Alright, so that's it. So once you predict your products, go back and balance your equation.
our next one we call ag wire. But if you know what ag is, AG, it's actually silver. So what we're going to use here is I'm going to use a piece of copper, and I've got some colorless silver nitrate solution. I'm just going to place my copper, which looks like copper, that bronzish color, into my silver nitrate solution, and I'm going to let that sit here for a few minutes. Now, I'm going to let that sit here for a few minutes, and what we have going on is we've got the copper solid, and I've got my silver nitrate, which is an aqueous solution. Remember, most of our things in here are not liquids except for water. They'll be aqueous. So looking at this, we can figure out what type of reaction this is. One thing alone, two things together in a compound. So if I have one thing alone and two things together in a compound, think about what type of reaction that would be. Be some type of replacement going on. Would this be single replacement or double replacement?
Single, because you have a single copper there.
You got it. So this is single replacement that we have going on here. Now, the single replacement, copper, would he want to go with silver, or would he want to go with nitrate?
Nitrate, the anion.
The anion. So the positive, the metal, never wants to go with the other metal. So he's going to make copper 2 nitrate, and silver's going to go off by himself. And we can see that right here, after I've left this alone for a few minutes. Check this out. So not only can you see the silver that's coating that copper wire, but now I have a blue solution. And this blue solution is actually my copper 2 nitrate. So I've created copper 2 nitrate solution, and I've created silver. You might be able to see the piece of copper wire up at the top. You might not be able to see that. All right, go ahead and finish off that reaction and balance it. So the next reaction we're going to do is called the thermite demo. Now the thermite demo is an extremely exothermic reaction. And exothermic means that lots of energy is being released, or just energy is being released in general. It's exiting the system. So this one, in order for the reaction to happen, we have to put in a little bit of energy, and then even more energy is going to be released when the reaction is taking place. So what I have here is I have a mixture, and it's called a thermite mixture. And in this thermite mixture, I have aluminum and iron 3 oxide. And I'm going to put a little bit into my funnel here that I've wet the funnel down. And a famous chemistry teacher once said, if a little is good, more is better. So I'm going to put just a little bit more, maybe even yeah, more is better. Okay, a little bit more here. So we've got some thermite in there. And then I'm going to put this far away from this demo, since it is exothermic. And then in order for the reaction to take place, I need some type of igniter or something. So I have a little, it's kind of like a sparkler. It's a magnesium stick. Now remember our rule, whenever we do any type of burning of magnesium, we want to make sure that that magnesium, we don't stare directly at it, that we look above, below, left, or right, but don't stare straight on. Being a video, you're probably okay, but just in person reminding us of that. And I'll put this far away as well. Now, in order to light my magnesium stick, I do need to have my monster burner. Okay, if I could get someone to turn off the lights for me, please. Thank you. And we're going to go ahead and light this. Just the wick. Pay close attention. We're going to see something fall. Ooh, did you see that? What we just did was we made some liquid iron. Ooh, lots of liquid iron. We made some liquid iron. And that liquid iron, we call that molten iron. And that liquid iron is at such a high temperature, it's thousands of degrees Celsius, such a high temperature that when that falls, the air temperature is so different that it cools it immediately and solidifies it pretty quickly. So we can see here, it's still glowing, but it is a piece of solid. So here I have my piece of iron. It's covered right now in some sand because I had a little sand back there to catch this. But I basically have this iron here, which is really cool. And then part of it stuck to the magnesium wick also, which is kind of funny. So, very exothermic as you saw, lots and lots of sparks, lots and lots of heat. And so if I have one thing alone, which is aluminum, and 2 together. What did we say? What type of reaction is that once again?
A single replacement.
Single replacement. And we know that one of the substances we made is iron, and you'll be able to figure out the other substance and finish off your balanced equation. Don't forget your states.
All right, so for our final reaction today, we're going to do another reaction where we have just one single reactant. And this reactant happens to be sugar, C12H22O11. So if I have one single reactant and I'm breaking it apart into multiple products, what do we call that?
Decomposition?
Right, decomposition, because I'm breaking one thing down into many parts. And it's kind of a funny title. It's called elephant poop. So once you see the actual reaction, then you'll know why it's called elephant poop. So we're going to head over to the fume hood here. Okay, so we're at the fume hood now, and we have a beaker full of sugar, about half full, and I have some 18 molar, so concentrated sulfuric acids. This is kind of nasty stuff. We're going to be careful with it. But the sulfuric acid, if you remember our reaction on the board, isn't actually in the reaction. It's only there to speed up the process of this decomposition of sugar. Because naturally it would break down over time, but it's going to take way too long for us to sit here and wait for that. So what do we call something that speeds up a reaction but isn't actually part of the reaction?
Catalyst?
Right, it's called a catalyst. So I'm going to pour some of this sulfuric acid inside of my sugar, and then I'm going to stir it with a stir rod. And you can already see it's kind of turning like a nasty yellow color. I want to make sure all that sugar gets exposed to the sulfuric acid, the catalyst. And I'm going to have to put this down pretty soon because it's quite exothermic. I can feel the heat being released through the beaker. And it takes a little bit for this reaction to occur. So we might have to stop the video and come back in a moment. So you can see the reaction going, and now we have, it's quite exothermic, it's releasing a lot of heat, and right there, this is actually water vapor that's getting released. So I'm going to turn the fume hood on. And you can see this black elephant poop, as we call it, is growing in front of our eyes. So what's really happening is that water vapor is getting trapped inside of that black substance. So looking at that black substance and the sugar, C12H22O11, can you predict what do you think that black substance is? Is it hydrogen, oxygen, carbon, water, carbon dioxide? What do we think?
Since it's black and it's solid, I'm going to go with carbon.
Yeah, it's carbon. So this is solid carbon as one of our decomposition products. And then we already said that all of this hot gas being released is our water vapor. So now you should be able to go back and write out the products and balance that decomposition reaction.